Here. So today we are going to start chapter 10 of grade 12 maths, which is vector algebra, and the topic of today's video is vectors, that is introduction of vectors and different types of vectors. So let's start. So first let me tell you the meaning of vector. All of you have learned about vectors in physics, grade 9 and 10 physics, and maybe 11 also, that vector is a quantity that have magnitude as well as direction. So any quantity having magnitude and direction is called a vector, normal vector. Now what is a position vector? So in the three-dimensional space, if we have a point, suppose P, with the coordinate x, y, z, then the vector with respect to the origin, that is, you can see over here that we have OR, OP with respect to origin. So we have OP, we can simply find the distance of OP, which is equal to under x square plus y square plus z square using the distance formula, and the direction is from O to P, O to P. Then this vector R is called the position vector of point P with respect to O. Whenever we say the term position vector, we simply means that the position with respect to the origin. Clear? You can see in the next figure that we have taken 3 points A, B and C, and they have the position vectors A, B and C. We say the term position vector because this is with respect to the origin. Clear? So pause and note down these points. Now there is a very important term called direction cosine. You can see that we have a point P over here, x, y, z. So we have the direction position vector, that is OP. Now this OP is making certain angles with the axis. Suppose these axes are alpha, beta and gamma with respect to x, y and z respectively. So these angles with the axis, that is x, y, z, are called the direction angles. Direction angles. And the cosine of these angles, that is cos alpha, cos beta and cos gamma, are called the direction cosine of the position vector R. And these direction cosines are denoted by small letters L, M and N. L for x, M for y and N for z axis respectively. Clear? So pause and note down this point. Now the magnitude R, the direction ratios denoted by A, B, C, and the direction cosine L, M, N are related as, remember this point, that L equals to A upon R, M is equal to B upon R, and N is equal to C upon R. That is, if L, M, N are the direction cosines, A, B, C are the direction ratios, and R is the magnitude of the position vector, then L equals to A upon R, M equals to B upon R, and N equals to C upon R. And we have very important formula that L square plus M square plus N square equals to 1. But A square plus B square plus C square is not equal to 1 in general. In few cases it might be equal to 1, but generally it is not equal to 1. Clear? So pause and note down this very important point. Now we have types of vectors. First is zero vector. So a vector is called a zero vector simply if its magnitude is 0, that is, the initial and the terminal point are same. You can see that if we have A, that is initial and terminal are A, B, initial and terminal both are B, then this will be a zero vector. So we simply say that if the initial and terminal point coincide, then we say that it is a zero vector. Unit vector is something whose magnitude is unit, that is 1. If the magnitude of the vector is unit, then we said that the vector is a unit vector. And the unit vector in the direction of vector A is given by vector A upon magnitude of vector A. Remember this point that the unit vector is given by vector A upon magnitude of vector A. Next we have coinitial. So two or more vectors are said to be coinitial if their initial points are same. We don't care about the terminal points, but if their initial points are same, then they are called coinitial vectors. Clear? So pause and note down these definitions. Next we have collinear vectors. So two or more vectors are said to be collinear if they are parallel to the same line. Or even if they are parallel to each other, then we say that they are collinear. We don't care about their magnitude, their directions. They have to be parallel to the same line or they have to be parallel to each other. Then we say that they are collinear. Direction and magnitude does not matter. Clear? Moving to equal vectors. So two vectors A and B are said to be equal if they have the same magnitude and a direction. Okay, if they have the same magnitude and the same direction, then we say that they are equal vectors. And we write equal vectors as vector A is equal to vector B. Then we have negative of vector. A vector whose magnitude is the same as that of a given vector, but direction is opposite. Then we say that the given vector is negative of the next vector. So we have a vector BA which will be negative of vector AB, and we write BA vector equals to negative of vector AB. Simply if we change the direction, magnitude, leave the magnitude, but if we change the direction, they must be equal in the magnitude, but we only change the direction. AB becomes BA. Clear? So pause and note down these definitions. So let's start exercise 10.1. And the first question is, represent graphically a displacement of 40 km 30 degree east of north. So here we have the direction north, south, east and west. So we have to go 40 km 30 degree east of north. So this is our north and we have moved 30 degree towards the east. So this is our vector OP. Now the magnitude was 40 km. So on this vector OP we have taken 40 km. So the vector OP is the displacement of 40 km 30 degree towards the east of north. Clear? So first we have to move on north, then 30 degree towards east, and on that we are taking 40. So we have a magnitude 40 and a direction 30 degree east of north. Clear? So pause and note down the solution. Moving to question 2. Classify the following measures as scalars and vectors. And the first is 10 kg. Now 10 kg is a scalar quantity because it involves only the magnitude. So it will be scalar. 2 meter northwest. Now 2 meter northwest is vector because it has both magnitude and direction. 40 degree. Degree is a scalar quantity because it has only magnitude. There is no direction involved. 40 watts is a scalar quantity because it have only magnitude, there is no direction. 10 power minus 19 coulomb is again a scalar quantity because it have only the magnitude. Then we have 20 meter per second square. Now 20 meter per second square is a vector quantity. We know that this is acceleration, and acceleration is the rate of change of displacement, rate of change of velocity, and velocity is no doubt, we know that it is vector. So since it has magnitude as well as direction, so this 20 meter per second square will be a vector quantity. Clear? So pause and note down the solution. Moving to question 3. Classify the following as scalars and vector quantities. The first is time period. Now time period is scalar quantity because it has only magnitude. Then we have distance. So we know that distance is a scalar quantity because it have only the magnitude. Force, we know that force is a vector because it involves both magnitude and the direction, in which direction the displacement should be there. Velocity is again a vector quantity because it involves both magnitude as well as direction. Work done is scalar because it involves only magnitude. It involves only the magnitude. Clear? It is very simple. If it has only magnitude, it will be scalar, and if it involves both the direction and magnitude, then it will be vector. Clear? So pause and note down the solution. Moving to question 4. In figure, identify the following vectors. The figure is there. 4 vectors A, B, C, D are there. We have to identify the co-initial, equal and collinear but not equal. First is co-initial. co-initial, that is having the same initial point. So in the figure we have 4 vectors A, B, C and D. Now A and B don't have the same initial point. B and C don't have the same initial point. C and D also don't have the same initial point. But if you look at the figure, vectors A and D have the same initial point. So A and D are the co-initial vectors. Done. Second one was equal vectors. So vectors B and D will be the equal vectors because they have the same magnitude and the same direction. A and C have equal magnitude, but they have the different directions, opposite directions, so they are not equal. And third is collinear but not equal. So it was very simple that A and C are collinear but not equal because they are moving in the same, they have the same magnitude, but their directions are different and they are parallel to each other. So they are parallel, their directions are not the same, so they are collinear but not equal. Clear? So pause and note down the solution. Over to question 5. Answer the following as true or false. So first is A and minus A are collinear. True, because A and minus A are negative of each other, and negative are just changing the direction. There is no change in the magnitude, they just change the direction, so they are collinear, they will be parallel to each other. Then second is two collinear vectors are always equal in magnitude. Now false, because collinear vectors are those vectors that are parallel to the same line. The magnitude does not matter for collinear vectors. So even if their magnitude are not equal, vectors can be collinears. So this statement is false. Third is two vectors having same magnitude are collinear. Now again this is false because they might be non-parallel but having the same magnitude. That is why this statement is false. Clear? So pause and note down the solution. With this we end the exercise 10.1. So solve the remaining sums and also the important examples given before the exercise. Till then, thank you and all the best.